Microservices architectures offer flexibility and scalability, but they can also introduce complexity, especially when it comes to performance. One powerful tool that can help: caching. When done right, caching can drastically boost both speed and reliability. In this video, we'll cover the best caching strategies for microservices, how caching layers improve performance, and share real-world examples of caching success. In microservices, caching isn't a one-size-fits-all solution. The distributed nature of these systems requires careful planning and selection of caching strategies that fit architecture. Let's explore the most efficient caching strategies and how they can improve your microservices performance. First up, in-memory caching. This strategy stores frequently accessed data directly in memory for near instant retrieval. For microservices, this means reducing response times for critical data like user sessions, configurations, and frequently queried information. Tools like Redis and Memcached are widely used for caching data in memory, giving you ultra-fast access. For example, instead of querying the database for user authentication on every request, you can fetch it from the in-memory cache to boost speed and reduce load. Now let's talk about distributed caching. This strategy distributes cache data across multiple instances to ensure consistency and scalability. It prevents single points of failure and allows multiple microservices to access consistent cache data across instances. Tools like Redis Cluster and Hazelcast are commonly used for this. In scalable microservices environments, this is essential. Each instance can read from and write to shared cache without conflicts. Now let's look at API response caching. This method stores entire API responses for reuse, eliminating the need for redundant processing. For microservices, it reduces latency and CPU usage for requests that don't change often, like product listings or user status updates. Tools like Nginx and AWS API Gateway offer native support for caching API responses. For instance, caching API responses for a product catalog ensures faster delivery of product information without repeatedly querying the backend. Database query caching is another powerful strategy. It caches the results of expensive database queries to reduce redundant requests. This can dramatically reduce the load on your database for read-heavy operations, improving system performance. Tools like Redis and PostgreSQL's pgstat statements can help with this. For example, dashboards or analytics services can retrieve cache data for common queries, avoiding performance hits during peak periods. Finally, let's talk about the cache aside pattern. With this approach, the application checks the cache first, and if the data isn't there, it retrieves it from the source and stores it in the cache for future use. This strategy balances performance and consistency, ensuring that critical data is cached only when needed and avoids issues with stale data. Redis and Caffeine are commonly used to implement this pattern. For example, caching product inventory data or user profiles in e-commerce systems can boost performance without compromising consistency. Let's take a closer look at how these caching layers translate into measurable improvements in performance and in reliability. First, caching reduces latency. By storing data close to where it's needed, we eliminate the need to fetch data from the slower sources, like databases or external APIs, on every request. For microservices, this means faster communication between services, ensuring responsiveness in a distributed system. Next, caching decreases server load by storing frequently requested or computationally expensive data. This offloads work from backend services, improves resource efficiency, and reduces the need for extra infrastructure. Caching also improves scalability. By reducing bottlenecks, we minimize database hits and heavy processing, allowing services to scale independently. This ensures smooth performance as traffic grows, even during peak periods. Another key benefit is fault tolerance. Cache data provides resilience when services fail or go offline. This prevents cascading failures, ensuring the system stays operational even if one service experiences downtime. And of course, faster response times lead to a better user experience. Caching ensures consistent, reliable performance across all services, even during high traffic periods. Now, let's look at a couple of real-world examples where caching strategies have drastically improved performance and reliability. Our first example was a client's e-commerce platform. The challenge was slow product detail pages and overloaded databases during sales events. We used Redis for in-memory caching of product information. This reduced response times by 70% and allowed the system to scale smoothly during high traffic events. On another project with a media streaming service, they faced high latency for global users accessing media content. The solution we implemented was a CDN to cache static assets at edge locations closer to the users. That improved streaming quality and reduced buffering, enhancing the overall user experience. In our last example, a client's SaaS application we worked on had slow reporting dashboards during high demand periods. By caching database queries for common reports, we sped up report generation and reduced the overall database load. So as you can see, caching is a game changer for microservices. When done right, it can drastically improve performance and reliability. From in-memory caching to distributed systems and cache-aside patterns, these strategies help you build scalable, resilient microservices that deliver fast and reliable experiences. At Keyhole Software, we specialize in optimizing microservices architectures. By carefully selecting and implementing caching strategies, we can help you reduce database load, boost response times, and ensure scalability, so your services remain fast and reliable, even under heavy traffic. If you're ready to optimize caching in your microservices architecture, the Keyhole Software team is here to help. Reach out today, and let's make it happen.